This is the King Tiger, arguably one of the most powerful German tanks of World War II. As the successor to the Tiger I, it was designed to serve as a spearhead tank for offensive operations. Although it was an awe-inspiring design, it did not achieve the level of battlefield success that its designers and German leadership had hoped for. The King Tiger can be examined in great detail to highlight both the features that made it legendary and the flaws that ultimately led to its downfall. This overview focuses on the most widely produced version, the Henschel turret model. The King Tiger was a massive vehicle, significantly larger than Allied heavy tanks such as the M26 Pershing and the IS-2. Its hull measured about 25 feet in length and extended to nearly 34 feet when the main gun barrel was pointed forward. The tank was over 12 feet wide and more than 10 feet tall. It was also the heaviest standard-produced tank of the war, with a combat weight of nearly 70 tons. The tank was operated by a crew of 5. The commander sat at the rear left of the turret, directly behind the gunner. The gunner was positioned at the front left next to the main gun, while the loader stood opposite him on the front right side of the turret. Inside the hull, the radio operator sat at the front right, and the driver was positioned at the front left. The King Tiger's armament consisted of a primary weapon, the 88mm Kampfwagen Kanon 43 ALA 71, along with two 7.92mm machine guns as secondary weapons. Though the 88mm gun appeared on other vehicles, it became the signature weapon of the King Tiger. Originally designed as an anti-aircraft gun, it proved extremely effective against Allied and Soviet tanks during the early stages of the war. Its success was one of the key reasons behind the development of the Tiger tank series. Because of its smaller size, the earlier Tiger I used a slightly less powerful version of the weapon. The King Tiger, however, was large enough to mount the gun in its full configuration, providing significantly higher muzzle velocity and improved performance against armored targets. Some historians later argued that the gun might have been too powerful for the targets it was designed to defeat. Its enormous size increased reload times and reduced ammunition capacity, both serious disadvantages in actual combat. The King Tiger primarily used two types of armor-piercing ammunition. The standard round was the Panzergranate 39-43, specifically designed to withstand the extremely high pressures inside the 88mm gun barrel. This projectile featured an armor-piercing cap designed to penetrate sloped armor by reducing deflection upon impact. A ballistic cap placed over it improved aerodynamic performance, allowing the shell to maintain speed and accuracy over longer distances. When fired, the round traveled through a rifled barrel, spinning rapidly as it moved forward. Upon impact with enemy armor, the ballistic cap would break away, allowing the armor-piercing cap beneath it to flatten against the armor surface and prevent ricochets. Moments later, a delayed detonator triggered an internal explosion. Inside the enemy vehicle, the result was often catastrophic. Against more heavily armored targets, crews could use the Panzergranate 40-43, a high-velocity round with a tungsten carbide core capable of penetrating even thicker armor. However, tungsten was scarce, and this ammunition was rarely used. For aiming, the gunner relied on the TZ-F9D telescopic sight mounted at the front of the turret. This sight allowed the gunner to switch between two magnification levels, one for locating targets quickly and another for precise long-range aiming. Additional triangular markings in the reticle allowed the gunner to estimate range and lead-moving targets using milliradian measurements. The King Tiger also carried two MG-34 machine guns. One was mounted coaxially with the main gun and operated by the gunner. The other was positioned in the hull and operated by the radio operator, who could guide the weapon using a unique half-dome aiming device that allowed him to aim through head movement. To defend against nearby infantry, the tank was equipped with a Nahverteidigungswaffe, a close-range defense launcher mounted on the turret roof. This device could fire smoke grenades, signal flares, or anti-personnel grenades. Because it was designed to break through heavily defended enemy positions, the King Tiger featured extremely thick armor. The upper front plate of the hull was heavily angled hardened steel, giving it exceptional defensive strength. In fact, historical records show almost no confirmed cases of this front armor being penetrated in combat. The turret itself was also heavily armored. The distinctive gun manlet, often nicknamed the Pig's Head, was designed to deflect incoming shells and prevent them from jamming the gun mechanism. The turret rotated using a hydraulic system powered directly by the tank's main engine. This meant the turret rotation speed depended on engine RPM. At high engine speed, the turret could rotate extremely quickly. However, this also increased the risk of mechanical problems. Inside the turret, the gunner controlled rotation using pedals and a lever. As the gun approached the target, he could switch to a manual system for precise aiming. The commander sat behind him, observing the battlefield through a cupola equipped with multiple periscopes arranged in a full circle. Opposite them stood the loader, responsible for loading ammunition into the gun. A trained loader could complete the loading process in just a few seconds. However, some crews intentionally kept the ready rack empty. If enemy shells penetrated the turret, stored ammunition could detonate instantly. The King Tiger was powered by a Maybach HL230 V12 gasoline engine, producing roughly 700 horsepower. Under ideal conditions, the tank could reach impressive speeds for such a heavy vehicle. But reality on the battlefield was different. Fuel consumption was enormous. The tank's 7 interconnected fuel tanks created a complicated network of fuel lines, making leaks difficult to detect and increasing the danger of fire. To reduce this risk, the vehicle was equipped with an automatic fire suppression system. Despite its impressive firepower and armor, the drivetrain was the King Tiger's greatest weakness. Many of its mechanical components had originally been designed for the lighter Tiger I. Under the massive weight of the King Tiger, these components frequently failed. The final drive system in particular suffered extremely high failure rates. In many cases, tanks broke down long before they ever reached the battlefield. The suspension system used overlapping road wheels and torsion bars, which helped distribute the tank's immense weight and improve stability across rough terrain. In combat, coordination among the 5 crew members was essential. The driver maneuvered the tank into position. The commander identified targets. The gunner aimed the main cannon. The loader prepared the ammunition. Then came the command: fire. The shell would leave the barrel at tremendous speed. In several documented engagements, King Tigers destroyed enemy tanks from extraordinary distances. Yet, despite its battlefield power, the King Tiger placed an enormous burden on German logistics. Maintenance requirements were extreme. As one veteran tanker famously remarked, 1 hour of Tiger operation required 10 hours of maintenance. The tank consumed huge quantities of fuel at a time when Germany was already facing severe shortages. Its massive weight also prevented it from crossing many bridges, and recovery was extremely difficult if the vehicle broke down. As a result, many King Tigers were abandoned and destroyed by their own crews during retreats. In the end, the King Tiger proved that armor and firepower alone could not win a war. While it was one of the most formidable tanks ever built, its complexity, cost, and logistical demands prevented it from achieving the decisive impact its designers had hoped for. Even so, the King Tiger remains one of the most iconic armored vehicles in military history.